All right, so we're gonna look at some questions on redox reactions. The first of which you're gonna be looking at is finding the oxidation states of the underlying elements. So I'm just gonna take these from here. Let's scroll down on our page so we could do the solutions. Oh, right. Now, first one, we have CrO4, 2 minus. We would use the X to represent the unknown oxidation number for chromium. We know that oxygen, there's 4 of them, and the oxidation number for oxygen is -2. Now, this is equal to the sum of the polyatomic, the charge on the polyatomic ion. So this is 2 minus. So X here, plus 4 by -2 give us -8. So X is equal to -2 plus 8. X is equal to plus 6. So the chromium has a +6 charge. Next, we're doing Mn2O7. We want to get the Mn. Now, because there's 2 of them, we have to put 2x here. We know that oxygen is 7 of them, and the oxidation number for oxygen is -2. Now, this here has our overall charge. This is a compound, right, of 0. There's no charge, there's no oxidation number to the top. So 2x plus 7 by -2. Carry this across 14. X is equal to 14 over 2. X would be equal to +7. So the Mn has a charge of +7. ClO3, 4 minus, and we're looking for the Cl, right? We represent this with a X. We know oxygen is 3 of them, and the oxidation number of oxygen is -4. Now, you see the charge here? So we put it equal to -4. So X, 3 by -2 give us -6 minus 4. X is equal to -4 plus 6. So X will be +2. So chlorine here has a oxidation number of +2. Going again, we have CaIO3 or in a bracket also 2. So calcium is a group 2 metal, right? Iodine, we're gonna use X, but there's 2 outside here, so this is 2x plus. Now we know the oxidation number of oxygen is -2. There's 3 by 2, that's 6 of them. Now the overall oxidation number charge on this is 0, so we put it equal to 0. And then we're going to work it out. So we have 2 plus 2x, 6 by -2 is -12 is equal to 0. 2x minus 10 is equal to 0. 2x is equal to +10. X would be equal to 10 over 2. X is equal to +5. So that I has an oxidation number of +5. Yeah? Going on to the other one. V5 Na2 SO3. Underline this. Sodium is a group 1 metal. So we have Sodium is a group 1 metal, so we have two of them, and that's +1. We don't know what this is. We're going to use our X. We have 3 oxygen, and we know that the oxidation number is -2. This would be 0. Right, so you're going to get 2 plus X minus 2 by 3 is -6 is equal to 0. X minus 4 is equal to 0. X is equal to +4. So the sulfur has a +4 charge here, right? This one we have VO2 plus. So V is what we're trying to find for the X. We have 2 O's, so we're going to put 2. We know the oxidation number is -2, and that's equal to overall +1. Yeah? So -4 plus 1, X is equal to 1 plus 4, X is equal to 5. So my V has a +5 oxidation number. And that's how we do the oxidation numbers. Yeah? All right. Next, we needed to write balance half equations. Let's take a grab at this one. Right, so we're going from chlorine, Cl2, right, to chlorine ions. So we're going to gain 2 electrons, right? And this is what's going to cause them to have that imbalance, to have 1 more electron than proton and result in an overall negative charge, right? Determine whether oxidation reduction has occurred. Well, if we are gaining electrons and we see an increase in oxidation number from 0, a decrease, sorry, in oxidation number, it means that it's being reduced. Reduction. Right? Number 2, oxygen to oxide ions. So similar, O2, right? It's going to gain 4 electrons to give 2O2 minus ions. And the same thing is happening here. It's going from 0 to 2 minus. So it's gaining electrons. After gain 4 electrons, because remember, each oxygen is going to get 2 additional electrons. Right? So this is also reduction taking place here. Right? 3, aluminum ion. So aluminum is 3 plus, right? And it's going to go to aluminum. So it has to get 3 electrons to go to aluminum. So we're going from 3 plus down. So it means it's also gaining electrons here. Reduction. And then we have tin. Tin is SN. Check my symbol for tin. Titanium. Zinc. Iron, cobalt. SN now is correct. Let me be sure I'm saying the right thing. SN is tin. The Roman numerals is usually give you an idea of what the oxidation number would be. So this is a +4, and it going to SN2 plus. So it gets in electrons as well in order to reduce the oxidation number. Notice all of them, the oxidation number is going down. right? 0 to negative, 3 plus to 0, 0 to 2 minus, plus 4 to plus 2, right? All of these are examples of reduction, right? So that's 1, 2, 3, 4. Well, I feel like I'm missing one of them. Yeah, I did. I skip out this one, magnesium. Let's do that one. Magnesium to magnesium ions. So magnesium is 0 here, but then I'm going to lose 2 electrons to go to magnesium 2 plus. So loss is taking place here. So this one is oxidation. And then 6 calcium, losing 2 electrons again to go to calcium 2 plus. Understand? All right, so let's look at the other one now. Here we want to identify what is being oxidized and what is being reduced, right? So I need to write each one of them. I did the first one as an example when we were introducing the exercise. Here we could see that the calcium has an oxidation number 0 and chlorine has an oxidation number 0. Now, when it forms the compound calcium chloride, right? The ion, calcium ion, has an oxidation number of +2, and the chlorine ion has an oxidation number of -1. So going from 0 to +2, that's showing an increase in oxidation number. To increase in oxidation number means that you have to have lost electrons. So calcium is being oxidized. And we said that whichever is being oxidized, or the element that's been oxidized, would act as a reducing agent. Chlorine, on the other hand, is going from 0 to -1. So that's a decrease or reduction in the oxidation number. So it's being reduced and it will be the oxidizing agent, right? Let's look at the next one now. So we have chlorine again with our oxidation number 0, right? Here, what we need to do is we cannot just look at the overall oxidation number of hydrogen sulfide. We need to think about what each individual oxidation number is here. So hydrogen is a +1, right? I could tell because that's usually the oxidation number of hydrogen, except in the case of metal halides. And I believe that's the rare instance where it will have a -1 charge. The sulfur is a -2. Now you're looking on the opposite side to see what's happening here. So hydrogen is a plus, chlorine is a minus, sulfur here is going to 0. So let's look at how the oxidation numbers are changing for each of them. If we look at chlorine, chlorine is going from 0 to -1. So chlorine is showing me that it is decreasing in its oxidation number. If it decreases in its oxidation number, that means it's gaining electrons. So that is actually being reduced. And if it's been reduced, then it is acting as the oxidizing agent, or abbreviating OA. Then the next one that we're seeing changes with is the sulfur ion. We're going from -2 to 0. That indicates an increase in oxidation number, right? We are going from -2, and if you think about your number line, we're going up to 0. So for that to happen, it means that it is losing electrons. So we could say that sulfur is being oxidized. And if it's being oxidized, it's acting as a reducing agent. It's facilitating right. Then we're looking underneath here now, we're going to barium nitrate, sodium sulfate. Let's look at them. Let's look at them like this. So barium is a 2 plus oxidation number. Sodium is a +1, right? Sulfate here seems to be operating. We would need to split these up so we could actually look at what's happening. Nitrate's still looking like a minus overall here. It's still looking like a minus overall here. Barium is still a 2 plus. Sulfate is a 2 minus. Sodium is a 1 plus. So you see, you can't look at it like this because then you wouldn't see anything that's happening. You need to look at the individual oxidation numbers on each of these elements so you would know which are being oxidized and which are being reduced, right? So here, nitrate, sorry, has a overall charge of minus, right? So nitrogen will be X minus 6 is equal to -1. X will be equal to 6 minus 1. X will be equal to +5. So we know that this is a +5 here. This is a -2 here. Na2SO4. We know this is a +1, so that will be 2 by +1. We leave the S as a X. We know this is going to be -2. And all of this should be equal to 0. So this is 2 plus X minus 8 equals 0. X minus 6 is equal to 0. X is equal to 6. Right? So we know that this sulfur here is a +6 plus 1 minus 2. Right? Barium is still a +2. BaSO4. This is 2 plus. Where you use this as a X plus 4 by -2. All of this is equal to 0. That's 2 plus X minus 8 is equal to 0. X minus 6 is equal to 0. X is equal to +6. So this is still a +6. This is a -2. Sodium is a +1. Right? NO3. Still going to be the same thing here. +5 minus 2. So this looks like a displacement reaction and not a redox reaction because when we look at this, if we pay attention to our oxidation numbers, there's no change in oxidation numbers. Everybody see that? So this is not a redox reaction. We check all of them. Yeah? Let's look at this one now. Nickel is in its elemental form, so that's 0. Copper here is going to be a +2. This is a -2. Nickel here is going to be -2 and copper is going to 0. So we could clearly see that nickel is going from 0 down to -2. So that's a decrease in oxidation number. And if we decrease in an oxidation number, it means it gaining electrons. So that's being reduced. If it's being reduced, then that means it's the oxidizing agent. Copper, on the other hand, is going from +2 to 0. Right? So copper is going from +2 to 0. So that means it's gaining electrons. It's losing electron. Nickel is going from 0 to -2. Is a decrease in a decrease in oxidation number. So it's gaining electrons. Copper is going from +2 up to 0. Sorry, I have this back to front. The nickel is being oxidized because it's losing electrons. right? Losing 2 electrons to go down to +2. Copper gaining electrons and it's being reduced. So this is the reducing agent. This is the oxidizing agent here. Yeah. Last one. Let's see. Copper still be 2 plus. This is now pay attention to the formula here, right? The formula here has CuCl. So in this instance, copper chloride, this is probably copper 1 chloride. Because we know that copper could have multiple oxidation states. Chlorine is a halogen and will have a -1 oxidation number. So that would mean that copper here is +1. And on this side, we have two chlorine ions, right? So that would suggest that this is a +2. So to go from +1 to +2, it means it's losing electrons. So copper is being oxidized. And I see we have a copper solid here as well too. Where it's going from plus to 0, so it's gaining electrons, so it's also being reduced. Yeah? So copper in this case is acting as both the reducing and oxidizing agent, because it's both being oxidized and reduced in this last one. Yeah? So that's the 3 questions that we had to look at. Next week, we'll be completing the others when we're looking at types of oxidizing and reducing agents.